Hi everyone, greeting from Indonesia. I'm Wahyu. It's an honor to present my research in this online summer school. My research is about specialized fraction division knowledge. I propose a model of specialized fraction division knowledge. It was built on three constructs. The first is specialized content knowledge. The second is conceptualization of fraction division. And the last is the representation of fraction division. Figure 1 is my model. I could not explore more about this model because of the 5 minutes that I have. So in the reference, I attach my work. You can refer to that. In the model, demonstrates a connected and flexible specialized fraction divisions. What I mean as a connected is students or prospective primary teachers' ability to translate across various representation in solving fraction division problem. And what I mean as flexible is on how they are able to differentiate conceptualization of fraction, which affect their works on the representation. The model has two functions. The first is can be used to examine, and in this presentation I'm going to show on how I use the model to examine the prospective primary teachers, especially fraction division knowledge. In my study, I gave 64 prospective primary teachers a set of talks which was built on the model, which was referred to the models. And in this video, I'm going to present the works of participants, just call it Anna. That's the description of the mathematical tasks that I designed, referring to the model that I propose. And I have 5 tasks. The first is a matching task. The second is on how the participants could solve word problems of fraction division. That is the sample task that I use. This is task 5, which aims to identify on how prospective primary teachers differentiate different conceptualization of fraction division. In my study, I use thematic qualitative content analysis for the analysis of the students' works and interview. And here are the results of Anna's works on task 1 until task 5. In the study, Anna was the only one who correctly matched the given contextual problems with the number sentences. And the remaining participants could not correctly match all the problems given, the contextual problems given with the number sentences. However, Anna was difficult to reasoning about the number sentences of the unit rate problems. And on tasks 2 and 3, Anna was able to construct pictorial representations in solving 4 word problems, but she had difficulties in determining unit, remainder, and question for the remaining 3 problems. Figure 2 shows Anna's work, Anna's error in determining the unit in the models. She properly used invert multiply algorithms. Her errors result in unmatched answer using models and algorithms. In this case, Anna explained that she preferred self-generate solution using model to algorithm at once. In the interview, this is the most important thing that I would like to present. In the interview, I asked how self-generate answer using pictorial representation relate to inferred multiply algorithm, or can the algorithm be justified through the constructed models? And Anna's answer showed that this question is too difficult to be answered by the prospective primary teachers, and we have read about these difficulties, not only primary student or secondary student, but the teachers also had difficult on how to relate the algorithm in fraction division and with the pictorial representation that they build. On task 4, Anna successfully made different contextual problem, but she missed one number sentence in which she wrote unrealistic context. In the interview, she realized about that. With the research help, she could come up with a right answer. On task 5, Anna was able to differentiate the contextual problem from those number sentences, but only from the words pattern and the question. In this case, she could not reach episodic situation comprehension, which make her understand the difference of each type of fraction. And in the interview, Anna was not sure about her identification, about the similarity. And I tried to let him to discuss about episodic situation of each problem, and finally it made her aware of different constitution of fraction division. And what we have learned from Anna's works on design mathematics that I use and interview to help develop prospective primary teachers, especially fraction division knowledge. The first one is about on how Anna worked from verbal to symbolic representations, and to support that ability, we must develop prospective primary ability to determine a number sentence from a problem context which relate to different conceptualization of fraction division. And the second one is to construct various pictorial representation and link them with symbolic representation. In this case, they will have a meaningful fraction division. And the task 2 and task 3 were designed to help the teachers, the prospective teacher, to construct various pictorial representations. The most important one is, and also the most difficult and the complex one, is on how we help them develop meaningful common denominator and infer multiply algorithms. And task 2 and task 3, I think we'll be able to help them to do this by modifying and refer to the works of the sequence tasks of from Greg and Greg 2007. And tasks 1 to 4 supports connected specialist fraction division. But to support that connected knowledge, we should make sure about teachers, prospective teachers' understanding of unit, remainder, partition, and iteration, as we see in the errors of Anna's work. And the last is on how to support prospective primary teachers' knowledge of differentiating conceptualization of fraction division by focusing on identifying episodic situation of our problem.